Okay. Let me just think there's some noise in the audio. Let me fix that quickly. Yeah, 1 second. Still getting some more, so let me problem is my computer sits really close to the to the microphone, so usually ends up making a lot of noise. Let me just check it quickly on the stream itself to see how bad it sounds. Okay, how does this sound? Okay, yeah. Sounds good enough, I think. Okay, so yeah, welcome back to the stream of me building my TweetTextarea component for React. It has been a while. If you've seen any of the previous streams, you would know that I have been having issues basically with building the component and connecting it to the test app that I am using, which basically you can see here. And whenever basically we made any change to the component and rebuilt it, it wasn't working properly. I tried to use yarn link, which basically, if we look at yarn help and look at the link command, where is it? yeah, it's here. So if we do yarn link help, tells us basically it creates a symlink to the package folder during development, so you can just create a link and add it in the test app, but that wasn't working properly when we made changes. Then we found out that there's an npm package called yolk, which does something similar using the link command as well, but it does it in a different way. It was working slightly better than yarn link, but it still wasn't working really that well. So in the last stream I said like I'll just stop streaming for a while until I actually figure out what to do with it, and that's what I've done. It's not a perfect solution, the solution that I figured out, but it works, so I'm happy with it for now, and I'll explain exactly what I did. So when I was looking at the documentation, I found out that yarn add can be used. I can't remember where I found it, to be honest. Maybe it was here. Yeah, here we go. Yeah, so turns out that actually yarn add can also be used on basically local files and folders, so it doesn't have to be just packages from npm. You can just you can have a package on your local system and just say yarn add basically the folder, or if it's gzip tarball for Linux users, you'll probably be familiar with that. Then yeah, you can also install it from the package from this tarball. So that was sort of the thing that I decided to use, but it's not that simple. I don't know, as I said, like I'm still relatively new to this, so I might be doing something wrong. There might be better ways of actually achieving this, but basically what I did is this. First, if you go to the package.json, you'll find that I have a clean script, which basically cleans everything. Just to be safe, I don't rebuild the package. I don't rebuild the component when without cleaning it first. So it deletes the dest folder, it deletes the package folder. I'll exactly tell you how is that created, and then it basically goes to the test app directory and removes the package, just to basically be safe that everything is actually working. Then we use the pack command, yarn pack command, and to actually build the a package from the current basically like build a component package, and we pass the production flag. This creates basically the tarball file that basically you can use. So you can just do yarn add and install the package, but the problem is the yarn pack command actually adds these div dependencies into the like they have them in the package itself, which would create problems because it has React as a dependency, and if the test app actually sees this, sees React as a dev dependency, it would freak out. So what I end up doing is I extract that compressed tarball, which ends up creating that package folder that you see here as well in the VS Code Explorer panel. Once I extract it, I remove the compressed file. Then I do something basically using the sed or SED. Not 100% sure how it's that pronounced, to be honest. But yeah, it's the sed utility or command on Linux, which edits files. So it would actually, if you open the package, you'll find first of all that it includes the dist folder and the source folder, and then basically it has a package.json. So when that package.json file is created, it actually has the dev dependencies. So basically it just opens that file and removes everything starting from the word dev dependencies to the first instance of a closing braces and a comma. So it removes all of that. So if you compare the two files, you'll find that they're exactly the same, except for the fact that it actually doesn't have the div dependencies. So that's what we do. Then the next script that we have is the install package, which basically goes to the directory, the test app directory, and then uses the onadd command and just installs that package, basically the package folder. And then I have a script that is sort of combines all three of these: the pack build, prep package, and install package. So it just runs all of them together. And then, if you remember, in the rollup config, I was using the rollup plugin command thing, which basically can run commands after rollup finishes building the bundle. So in this case, once the dist folder is created, we run the yarn create package command, which, if you remember, basically just runs all three of these commands. And we already, in the build command, we run the clean command before, so we remove the previous installation, create the bundle, then basically create the package. The only problem with that is, remember we had a yarn start script previously, which would continuously build the bundle and like in watch mode. However, the problem is this solution that I've come up with doesn't seem to work well with watch, with building in watch mode, basically, and that created a problem because I couldn't use watch mode, which meant that every time I made a change, I would have had to build build the bundle on my own, or like manually, and before I can actually use it. But I didn't want to actually keep doing that. I wanted to have something similar to what we had in watch mode, where whenever we save a file, we would actually it would actually just rebundle it and reconnect it to the app. So I decided to rely basically on Visual Studio Code in this case, which I had to do two things. I basically created a build task, which does nothing. It just runs the yarn build command that we have defined here, which, as you know, once we run that command, it would also run that command afterwards. So basically that task already does everything for us, but I wanted to run it when whenever I save any of the files that we have, like the TSX files or TS, or any of the files that are related to the package basically. So I've looked for a plugin and I found that there is one called I think run task on save or something like that. Let me try to find it quickly. Yeah, I think it's this one. No, not this one. It's trigger task on save. This is the one. So this basically you would tell it to run a specific task, like the build task, and you would tell it which files do you want to trigger basically this task when they are saved. So if you use like the exclamation mark, basically it tells it don't use these files. So yeah, I'm not going to actually go too much into this plugin for this extension, but yeah, it's called trigger task on save, and I basically have it defined in here, and it runs basically on a lot of different files that we have. So we can actually, once I save a file, it actually rebuilds, and I'll show that to you. Like now that I have made a change, if I resave again, you'll notice here that it automatically starts building. Does a lot of stuff and takes a little bit of time. This is another issue of like this is one of the sort of disadvantages of this solution, is that because we're doing this thing ourselves rather than using like something like Yark or Yarn or anything, it's a bit slower. But yeah, it was either that, or we would have had to basically just deal with a lot of weird issues, and yeah, I'd rather basically have everything working properly, even if it's slightly slower, than having to deal with the issues that we have. And as you can see, basically the app is actually compiled and it's running properly as we expect. The other thing that I did, again, if you've seen any of the previous streams, that you would know that the last stream basically we found out that in the tests, the playwright tests that I had written at the start of basically creating this component were not working properly, and I'll explain why they were not working. If we go to the GitHub repository and we go into source tests and just take one of these tests, no, not this one, paragraphs. So if you can see here, and I'll let me also just zoom in a little bit here, so everything slightly clearer on the stream. So if you can see here, what we were doing basically in these tests is that we were actually checking the HTML of the editor, basically the div, which is the TweetTextarea that we're using. We were actually, in the test, we were checking the inner HTML of that component, and testing to check if it equals that thing, and like we're doing that for like in all of the tests basically, and we were having different values and checking all of that. The problem with this approach is that while all browsers essentially do the same thing that we want, like they display visually, they display the same thing to the user. The way they do it in the HTML might be slightly different. So for instance, Firefox tends to add a line break node at different times from when Chrome does it, and that means that if we check against the HTML, it basically means that we'll either have to have a lot of variations depending on the browser, or different tests for each browser. It didn't make a lot of sense to keep doing that. And the thing is, because this is end-to-end testing, what we're interested in is basically what does the user actually see on the screen. We're not interested in the specifics of the HTML. If Firefox wants to add a line break node, that's fine, add it. As long as visually things look the same, we don't care about the HTML. So what I ended up doing is I basically scrapped all of these tests that were using the HTML and decided to use to do it in a different way. I'm not going to go into the detail of how I did it because that would take a long time, and we've already spent a lot of time on the tests before, but I'll show it to you quickly. If we compare, for instance, those two tests here, here basically what we're doing is, because basically what we want our component to do is whenever the user starts typing some text, if the editor is empty and it doesn't have anything, it would create a paragraph element and add the text into it. As I said, we were doing that testing that through the HTML, the inner HTML, but that didn't work. So what I ended up doing is I ended up basically using Playwright's locator. So we were using locators already to find the editor. Think of the locator like, if you're familiar with vanilla JavaScript, basically it's like the similar, it's not exactly the same, but it's similar to the query selector function or the find element by ID function. It basically searches the DOM basically for a specific component, and if the multiple instance of an element or something, the locator would basically grab all of them. So in this case, we use the locator in the editor, and then we use the locator again this time, like we use it basically on the page to find the editor, and then within the editor we use the locator again to find any p elements. And then for this test, we expect that the p locator would be visible. You'll find, like, which basically means that you'll find a p node or a p element inside that editor, and the count basically will be 1, because as I just said, basically the locator, if there are multiple instances of that element we're looking for, it will basically grab all of them. So we don't expect that will be multiple instances in this case, so we expect that it would be 1, and it would that this only instance of the p element would have the text hello from TextArea, which we actually added in here. Another thing that we can add here is this. I'll add it quickly because when you do the delay, it actually types like if a normal human being is typing, rather than just adding all the text at once, which I found out that if you add all the text at once, it can create some issues and make the tests fail when they're actually are working properly. So yeah, just for the sake of this, we'll add the delay. So yeah, as I said, I'm not going to go deep into how I actually set up these tests. Once I am done with them, I'll push. Once we're done today, I'll push all of that to the repository, the GitHub repository, and you'll be able to actually look into that, and along with the Playwright documentation, which basically exists here, you'll be able to actually figure out a lot of what we're doing. Like it's really simple. As I said, like I am not doing any fancy stuff with the like using Playwright. I'm just basically doing some basic stuff to make basically everything work as I want it to do, and to check the components. Another thing I did with the tests is that, like, again, if we go back here and go to the tests, you'll notice we've had like 7 files basically, just 7 test files, but now we have a lot more. What I did is like they're basically the same tests. I haven't added any new tests or anything. All I did is just I split some of these files into separate files. The thing with Playwright is that it runs each test file using one worker. So if you have one long file, it will basically just take that file and go through it test by test, like one test at a time basically. And if these tests are not related in any way, and like if you can run them separately, the shorter your files, if you split your files, basically you'll have a chance to run multiple of these tests at the same time. And because we have loads of tests, we had loads of tests in each of these files, I ended up just splitting them into multiple files basically, so we can run across them faster, especially because we also have a lot of projects here, because we're testing across a lot of different desktop and mobile devices. Our tests are always going to be slow, so the faster, like anything to make them actually run faster would be much better. So splitting the test files into, like, breaking them into multiple files is actually not a bad solution. So that's what I've done. And the last thing I did during that break I had was that I basically, because again, if you've been here for any of the earlier streams, you'll remember that I said that before I actually started building the actual component, I built a prototype for this component where I tested a lot of my ideas and tried a lot of different things. But when I actually started building the component, I came up with a completely different idea that simplified a lot of the things that I tested while building the prototype. And the problem for me was that I actually haven't tested this idea, and I have no clue. I had no clue if this idea was going to actually work or not. So while I was on a break trying to figure out a lot of the issues that I had with building the component and connecting it to the test app and all of that, I decided that it might be a good idea to actually test the new method I came up with for basically achieving what I want in the component. And I'm pleased to say that it seems to be working fine. I tested it and ran the playwright tests, tested it manually and then ran also the playwright tests, and it seems to be working really well, except for basically on Apple devices. So we'll have to basically we'll build the component using that method, and I'll explain exactly what I'm doing. And we'll start actually building that in this stream, and I'll probably be using the code that I've already written to sort of speed things up a little bit, and so we can actually see things happening on the screen finally. But yeah, the idea basically is Apple devices do not seem to work, so we'll build the files, and since it seems we'll build the component using basically the code I figured out already, and from there basically we'll probably have to test on Apple browsers to see exactly what is happening and why they're not behaving the same way that all of the other browsers are behaving. And yeah, we'll take it from there, and hopefully we'll figure it out. If you want, might be a good idea to actually show you the component actually working. So let me switch to the other version I have here, which I was working on it offline, and let's just do this. Yarn build. As you can see, it's already updating the app, and some things happening now. We've basically we cleaned we removed the existing installation, and yeah, as you can see, it says compiled successfully. If we now go here and start typing something like hello from 100 days of code to, for instance, something like that, or the other way around, as you can see, seems to be working fine. If we also run the tests, and these probably will take a little bit of time, So we'll run them just for Chrome browsers. There are 141 tests. So yeah, we'll keep them running, and yeah, you'll see that basically all the scenarios that we've created while at the start of this project, and all these scenarios that we've actually ended up putting into tests, they are all actually passing and working on the desktop version of Google Chrome. They're also working fine on the desktop version of Firefox, desktop version of Edge, as well as basically the mobile versions of Chrome and I don't think we have, like, yeah, as far as I remember, I think the Playwright configuration did not support testing Firefox on, yeah, we were just running basically on Chromium. Firefox wasn't working because of like a limitation in Playwright itself. I'm not sure why it exists, but yeah, we decided that we're not going to test for like Firefox on the mobile anyway. But yeah, as you can see, up until now, we don't have any failing tests. They're all passing, and I think this is the last test file we have anyway. It's the slowest one of them. It's testing something with the URLs, and because it's still a long file, even after splitting it, it just takes a little bit of time. But as you can see, we had 141 tests running, 141 tests passing, and yeah, it seems to be working fine. So there are some bugs, of course, that I found out that probably will need some addressing. Like, we'll need to figure out basically how to fix them, and they are not actually tested in the scenarios we have. But yeah, we're not gonna jump ahead of ourselves. We need to actually build the component on the stream to make sure that it's actually working properly. So we'll go back to the stream version of the component and just do another build here, so we can actually switch the test app to this version rather than the offline version I created. And something is not working. What is it? Decompression. Okay, maybe we need to just run it again, just quickly. Clean. Okay, that's fine. This module. Okay, that's alright. Yeah, build. Let's try again. Yep, here we go. Now if you go here and type this, hello from name side to 100 days of code, and as you can see, now we're back to not having anything formatted, or yeah, we're back using the non-finished component. So yeah, I will just go get a drink quickly, and I will be back in like 2 or 3 minutes. No, forgot that. Yeah, see you in a bit. Okay. Yep. So first thing we need to do here is we need to fix something, like a small issue that we had in the code that we already wrote before. So I know the fix, but I don't remember exactly what the problem was. So let me just see what it was. I can't remember. I think it's this. As you can see now, the this p node doesn't end up being deleted, which unlike in Firefox, if I do this and I do the same here, no, it doesn't end up getting deleted as well. So maybe the problem was in both of them. I can't remember, but yeah, the problem basically is yeah, the problem is basically we were only deleting the last child when the editor is empty if the tag name of that editor is not p, which means that it's not a paragraph element. Yeah, that is just creating some issues for us. So instead we we basically just remove that if statement, and we also basically added a return here because we're going to be doing other things in here, and we want basically to make sure that when the editor is empty, like when we empty the editors of any child nodes, of all basically child nodes. Once the editor is actually empty of the text, we don't try to do any of the other stuff that we've had, and we no longer need this one, so we can just do this. And once we save and rebuild the component, hopefully everything works properly. And yeah, now when we go here and type something, then delete that, then delete that, as you can see basically the editor is empty, it no longer has any children. And the same thing happens in here. If we do this and we do this again, as you can see the editor now is empty, it doesn't have anything inside, like any child nodes basically inside of it. So that was one issue that we've addressed. And in the handlers, let me just clean some things up here. Yep, that's fine. Yeah, we need to remember to not save as frequently as I usually do, to avoid having to rebuild the component time and time again. The other thing I want to do before I actually explain how I'm going to do the formatting, the new method basically, I came up, like, probably, like, I'm not saying I came up with as in like came up with something new that no one else is doing. It's just it's different from what I've been doing in the prototype basically. Yeah, there's one more thing that we need to do, and that is in the before input event listener we need to handle the space key, because Firefox does something that sort of can create some issues when we're actually working with the editor, is that, like, if I type something in here like hello, and this would be formatted and converted into like an element with like inside a span, and sometimes if I add a space afterwards and type something, in some cases, I'm not sure exactly when it happens, but in some cases it happens, and the that space would end up being deleted automatically by Firefox. It doesn't happen on Chrome, but the fix for this would work on both Firefox and Chrome, so we would handle it. And basically what we would end up doing is we would intercept the space character, and we would basically hi Korbos, I am actually Egyptian, but welcome to the stream first of all. But yeah, I'm actually Egyptian, and but I currently live in the UK. So yeah, are you Lebanese? Ah, okay, nice to meet you. I've never been to Morocco, to be honest. Would love to visit at one time, but yeah. Welcome to the stream, and yeah, if you have any questions about JavaScript, let me know and I'll try to help. I am also relatively new, like I've been using JavaScript for a while, and I'm not completely new to programming. But yeah, if you're looking for good resources for JavaScript, I don't know if you've seen this one. If you like learning by reading, then I would really recommend the MDN web docs. They have some good I think the getting started resources now. Trying to find JavaScript. If you're looking, they have the complete beginners, JavaScript basics, and it takes you. That's of course if you are into learning by reading. If you prefer videos, I would definitely recommend Free Code Camp. I think they have. Oh, sorry, wrong video. Free Code Camp and JavaScript. I think they should have. They will have. Definitely have. Yeah, they will have the different courses. The most up-to-date one would probably be this one. It's almost an 8-hour course. So yeah, and as I said, happy to answer any questions if you want. Perfect, great. I'm also available on Twitter. My Twitter handle is on the screen, but I'll also paste it to the chat quickly, so you can actually let me just paste it quickly. Yep, that is my Twitter profile. So yeah, let me know if you have any questions. Yeah, you're welcome. So yeah, let's go back to this. So yeah, as I said, what we're doing basically is, because the space character ends up being handled differently between Firefox and Google Chrome, we need to specifically tell the component what to do when it actually encounters the space character. And what we're going to do is we'll actually tell it to convert that space character into a non-breaking space using the Unicode Unicode literal for the non-breaking space, which I have found about this one from here. JavaScript, insert white space node, that's what I'm looking for. And basically on Stack Overflow, that's what they recommended as a fix for the issue with Firefox. You basically use that and tell it that you actually want to create a non-breaking space or a white space, and this way it shouldn't actually be deleted. So that's what we'll do right now. In this case, I will just copy the code I have, and I'll explain exactly what it does. So let's go here quickly. Yeah, and so let's go here and we will sorry, doesn't seem to be copying it properly, so let me just do this, and so, yeah, that works. So basically what we're doing here is we're just checking if the key that the user pressed is the space key. If this is the case, we will grab the start container from the range. If you remember, we basically the range basically tells us what part of the document is selected, and we've went through we've explained the range a little bit, the selection and range, in the previous stream, but basically in the range you have something that's called the start container, which is where your selection actually starts, which node, and it's usually a text node. So what we want to do is, if the user presses the space, we want to create a text node within the paragraph. So we want basically the node to be the immediate child of the paragraph that we've already created before. So however, we know that when we format a text node, we'll actually end up wrapping it within a span element. So what we do is we check to see if the text node, which is the start container in this case, is wrapped in a span element. Then in this case we would prevent default, and we would make the node basically the parent element. So what we're doing is we're actually selecting the span element, and then we try to find where that element actually exists in the paragraph node, which is what we're checking here. Like we have to do this check because I'm using TypeScript, and TypeScript, the .parent element returns either an HTML element or null, because if the element doesn't have a parent, then it would be null. So we need to tell it, like, if it exists, which in this case it will always exist, because we know that the paragraph node will exist. So what we'll do is we'll go through the child nodes of this parent, which is the paragraph, and once we find the node that we're looking for, the span element that we're looking for, we'll set offset in parent to the index of that +1, because we want to create the text node after that element, basically. And then we would break, and then again we're doing this check because of TypeScript. We're making sure that offset and parent ended up being defined, because if we couldn't find the node, which like we would, but yeah, if we couldn't find it, then yeah, we just keeping things safe. What we do basically is we set the start of the range to the parent element, the node.parent element, which in this case is the paragraph, the paragraph node. Actually, let me maybe make it clear. So const paragraph node equal node.parent element, and in this case paragraph node. So we can actually paragraph node and paragraph node here, and then paragraph node And yeah, just to make sure basically that this is clear, this is the paragraph node we are that we're basically setting as the start of the range, and we tell it to actually add that in, use the offset in parent as the start offset. So basically what is happening here is we're putting the cursor after that that span element that we found, and in this case we'll just add we'll use the code that we've found on Stack Overflow, which uses this Unicode literal for the non-breaking space, and then we will insert the node in there, and we would just set the start of the range to that text node that we've created here, and to the basically to basically the start offset would be 1, which means that the cursor would be after the space, and then we would collapse the range so it's not selecting anything, it just has a cursor basically in here. So like it would have the cursor in here, for instance. However, come to think of it now, I think this might actually create a small problem. If we basically press space in the middle rather than at the end of the the formatted span, I think that would create a problem. Let me actually test that quickly in the local version of this, because I think that would create an issue, and if it does, I'll fix it quickly. So let's go here and hello at AM site 1989. Okay. Yeah, see, that's what I expected. I wanted basically to add a space in here, but instead it didn't do that. It actually jumped to the end and just added a text node. And the reason is because we're telling it to do that whenever it's inside a formatted element, but we only want it to do that when it's inside a formatted element, but at the end of the text that exists. So we only want it to do it when the cursor is here, not when the cursor is anywhere here. So I'll fix that quickly. Let me see, just so I'm fixing it now in the local version of the component, and if that fix works, then I'll explain exactly what I'm doing with it. So let me see, hello at AM side. Yeah, see, now this works properly. If I do that, yeah. Okay, so basically what I'm doing here is when I actually get the start container from the range, I also get the start offset, which is basically tells us where exactly within the start container is the cursor. So if it's a text node, it tells us how many characters in. So like, let's say that the node has a text that is 10 characters long and the start offset is 7, then it would be after the 7th or 6th character, it would be so yeah, let's just explain it quickly. If we have like something like hello, and this is the start container, basically is the text node, which is this one, and let's say that the start offset is 3, so this would be 0, 1, 2, 3. So if the start offset is 3, then it would basically be after the 3rd character. So yeah, that is the idea. So what we're doing is we're grabbing the start offset from the range, and then we're adding another condition here, which is and if the start offset is equal to node.textContent.length, then in this case do that. So if the cursor is not at the end of the text content, just ignore that, handle it normally, and everything would work as expected. So we're building that at the moment. We're not going to be able to see it because now we're building the stream version of the component. This one doesn't have the formatting yet, but we're going to add it hopefully soon enough. So yeah, now we're ready basically to explain what exactly is it that let me just make sure that everything is working. Yeah, no errors or anything, so yeah, everything's working fine. And so yeah, so the technique I'm doing basically is in the prototype, what I did is, if you remember when we talked about the regular expression patterns that we're using, I said that initially the patterns that we're using were just checking basically if a certain word matches the pattern, without actually checking for what comes before or what comes after, and that actually is needed. So in the prototype, what I ended up doing is I ended up checking that programmatically, basically by creating conditions and doing a lot of stuff to actually check, like, okay, does this word match the pattern? Yes, okay, but what comes before it and what comes after it, and should it be formatted, and all of these stuff basically meant that the logic for the prototype was very complicated, and I ended up having to even re-implement some of the stuff that already exists in the browser. I shouldn't have to re-implement that. My code should just use these to make things easier. So the technique the different technique basically that I thought of when I actually started building the component relies on something very simple. I'll explain it by drawing basically. So let me just bring up a drawing program I will use. just anything. But that is way too bright. Yeah, here we go. So the idea is, let me grab something that I can use to try as well. Maybe something like this would be good. Yeah, that's fine. So the idea is like we'd have any text. So like, let's say we would have hello from, excuse my garbage handwriting. So yeah, we would have that, and the concept is basically that while the user is typing, we are checking the text against the patterns that we have, and if any word in that text matches the pattern with the words that come before it and the words that come after it, it would be automatically selected and formatted, basically by wrapping it into a span element. So this would be converted into a span. The problem with that is once one word is wrapped into a span, then the surround text basically doesn't, like, you cannot check the surround text with the pattern. So if for instance now, okay, the user typed this but then went back to here and decided to delete the @ character. In this case, or let's not actually delete the @ character, because I think this would work, because now it doesn't even match the pattern. Let's say that the user came back here and decided to delete that space. So let's say that the user decided to delete the space between the word from and the word side. Oh, damn it. I think I typed on the, yeah, here we go. Let's put that one here. So now the text is this: hello from but this is span and this is text node. And the thing is, if you check the text of this span element against the pattern, it would actually still match on its own, because there's no way to actually check the pattern, basically the pattern against what comes before it. And in this case, this shouldn't be formatted because the space between the word from and the word side is deleted. So if we actually go to Twitter quickly and do this, so hello from side, if we delete the space, it should actually be deleted. The formatting should be deleted, but there's no way using the patterns on their own to actually do that. So the way I'm doing it is, when we tested it initially, we did, like, if you remember in, I think, the previous stream or the one before that, we've actually did a test where we were just, whenever the user types something, we copy everything in the editor as text, paste it and reformat it. But that meant, like, we literally, if the user had like something very long typed in there, it would actually you would actually have to do that every time. and the thing is, there's no point in doing that. So like, let me try to explain it in a like slightly. Let's say I have words like hello from main site, hello to 100 days of code, and then hello to React, for instance. So let's say I'm basically like, the user is typing something here and then they went back and deleted this space. What would when we did an initial test to actually see if things are going, like the patterns are going to work or not, what we were doing essentially is that we were literally selecting all the text in here, deleting it, and then adding it as a text. We won't be able to add it as a text in here, so let's just add it like that as a non-formatted text, and then going all over it again, and just basically anything that matches is like we format anything that matches, and anything that doesn't match is not going to be formatted. That works. It's not the like it works fine. There are no issues with it, and it's very simple to implement. We just needed to calculate the cursor position so we can actually put the cursor where it was before, and just formatting everything from scratch. But that's a problem. Like, imagine if we have several like paragraphs and of text in there, then we would be doing that every time. For Twitter's actual input, maybe it makes sense, because at the end of the day, Twitter is limited to a certain number of characters. But the thing is, I don't think even that Twitter is doing it that way, because though you're limited to a certain number of characters in the tweet, the text area, like the input itself, is not limited, so you can exceed the number of characters. So I can copy and paste like an entire article in here, and I think it would be pasted. So like, let's try something quickly and see. Like, I think, yeah, I can literally paste the entire thing in here, and I'm exceeding the limit by 460 characters. So if all of these have, like, if I added this, it will be formatted. Like, and if we're doing it that way, if we're selecting all the text, deleting it, pasting it, formatting it, it gets a little bit inefficient. So the idea basically is, instead of doing that, let's say that I have something here, hello from $200 days of code, and React, for instance, JS. And again, ignore my garbage handwriting. So what would end up happening is, this would be a span. This would be a span as well, and this would be a span, while everything else is just text nodes. So this is text, this is text, and this is text as well. And let's assume that, for instance, the user has the cursor here and they delete that space. So what ends up happening is, we get the current node, so which is this, text node in here that lives inside that span. So we get current node. Let's actually number them: span 1, span 2, and span 3. So current would be span 2. Then we get the previous node to, like the node before it, whether it's a text node or another span element that is formatted. In this case, the previous, so let's say this is text 1, text 2, and text 3. So previous would be text 2, and then we get one node after it, again, whether it's a text node or a formatted span element. So next in this case would be text 3. Then what we end up doing is basically deleting all of that, and the creator cursor is a bit annoying because it sort of disappears sometimes. We basically end up selecting all of that text in the 3 nodes that we have, deleting it, pasting it as a text, and then formatting it. So essentially we're doing the same thing we were doing when we were deleting all of the text in the editor, but it's slightly more efficient because now we're just doing it to 3 nodes rather than the entire contents of the text area or the tweet input basically. So let's try to explain it again here. So if I do hello from Saeed, 200 days of code and React.js. So we have that. So yeah, and as I said, like let's say the user is basically here and they want to delete that. Like the input basically is that they pressed backspace and deleted the space between 2 and the hash, like the hash 100 days of code thing. So what would end up happening is basically we will select all of that, delete it, and insert it again as text. So like we insert it basically like that as text, not formatted or anything, and then we would go over, it would be basically inside of a text node. Then we would go over the contents of that text node, and anything that matches would actually be formatted. And another thing that we'll be doing is that we'll actually be going over the text node in reverse. So let's say, and 200 days of code, let's say that maybe it was something like this actually. So now basically when we go over the contents of the text node, we'll find 2 matches. So we'll first format the last match, then we basically be going down. So then we'll format that one, and then if there's another one before, we'll format it, and then basically it would all be in here formatted properly and working as we expect it to work. And the reason we do the formatting in reverse is because of we're setting, like when we want to go with the range, like it's like doing it properly in the correct order was creating some issues. I can't remember exactly what it was, but the solution was that it would be much better to actually do it in reverse. Let me just have a sip of water quickly because my voice is breaking. Yeah. So yeah, that is basically the concept behind how we're going to handle this. It's select the current node and the two nodes adjacent to it. Delete them, repaste them as just plain text, plain non-formatted text inside a text node, and then go over that text node, formatting everything that matches any of the patterns that we have in reverse order, basically. So yeah, that is the way we're going to do it. And now we can actually start basically getting that code and building everything. So let me and okay, so first thing that we're going to do is we're actually going to get that one here, because we're going to use the input type for other purposes as well, so we need it to be outside of that if statement. And the first thing we're going to do is we need to actually now start the formatting. So the formatting should work on anything, any basically type of user input, except when the user actually presses the enter key. So first we need to actually create the function that does the formatting. Let's see. I'm just looking at the code that I've written off stream, trying to figure out what is the best way to actually sort of break it down. Okay, so the function that we're going to be using is going, for now at least, going to be called format, and it's going to take these parameters basically. Let me just create things here, it's going to return nothing, so it's going to be void, and it's going to take a range parameter, which is of type range, of course, text node type text, and pattern again of regular expression, and an optional final node if we want to actually set the if we want to define which node we want basically the cursor position to end at, we're going to use the final node. If not, we'll just set it to the span element that we're going to create. So here's what we're going to do. First, we will find the all the matches for the regular expression patterns that we have. So we're doing matches text node. Basically, we're going over the content of that text node that we're checking. Match all, and we check using the pattern that we're passing as a parameter. Then if matches, we'll convert that into an array so we can grab iterate over it like in a much easier fashion, and then we will actually reverse it as we said. Like we need basically the match, like we need to go over the matches in reverse so we can actually do it properly without any issues. Like as I said, I encountered issues when doing it in the correct order, so we do it in reverse. We start with the last thing that matches, format it, then we go backwards from there. So for const match of match array, we are going to do basically grab the match. So text match equal, as you remember, if I bring up the patterns, basically when we initialize the pattern, what we end up doing is, this pattern is of course too complex, so if you haven't seen any of the previous stream, you might need to go back to these ones and where I go over the patterns. But basically we have 4 patterns that are all wrapped inside regular expression groups, and basically these groups are group 1, group 2, group 3, and group 4. So we have the URL, the hashtag, the mention, and the cache tag. So this is basically, this ends up being like each match object has 0, 1, 2, 3, 4. 0 is everything that matches, and then 1, 2, and 3 and 4 are basically each one of them represent one of the groups that we have. So match 1 would be the URL, and then match 2 would be the hashtag, then match 3 would be the mention, and finally match 4 would be the cache tag. So what we're telling it here basically is to check the text, basically check the match object that we have and see which actually, if it matches a URL, then it will be match 1 and the other ones would actually be null. So if it matches a URL, then it's a URL. If it doesn't match a URL but it matches then it might match a hashtag. If not, maybe a mention. If not, maybe a cache tag. It would have to match one of them because that is the pattern that we're using. So if the pattern matches, then it definitely matches one of them. Again, we are going to check if text match. Again, this is just to make sure it will definitely match, but again, this is to please TypeScript, basically, because to get rid of the errors that TypeScript will generate, because technically the way, like, I know that it would definitely match, but TypeScript cannot be 100% sure. So we are telling it, like, if this is not null or undefined and the match index again is not undefined, maybe to be safe, or match.index is not null, and wrap this one just to be safe. Then what we'll do is we need to grab the basically the location, like where the actual word that needs to be formatted starts. So that's what we'll do, and the way we're going to do that is by comparing match 0, which is everything that matched in the text that we have. If it exactly equals the text match, this means that let me explain exactly what happens in here. Let's go to this. Let's say, for instance, I type this. If we pass that text to the pattern, match 0 would actually be equal to this, so it will match the space character, this space, because we're looking for the character that comes before to make sure that it actually works properly. So if it matches that, then match 0 would be equal to that, but text match would actually be equal to that because that's what's in the group. So what we do is we compare match 0, which is this one, to text match, which is this. In this case, they won't match. So when they do not match, we need to do basically match.index +1. And the reason why we're adding +1 here is because match.index is actually this, which is again we'll put the cursor just before the space character, and we want it just before the add character, so we just add 1 in here. However, if this was at the beginning, then match 0 would be this and text match would be this. So in this case, match the start point where we actually want to put the cursor is exactly match.index. So that's what we're going to do here. We just tell it to use match.index in this case, and it's complaining about something. Okay, it's possibly undefined. So I think we don't need this because I think match.index only returns undefined. So we don't need to check if it's null. And again, I saved. I shouldn't have saved because it keeps rebuilding unnecessarily. Then we would set the start of the range. That's what. As you can see, it's slowing down a little bit because it's building the component. Let's wait until it finishes. Yeah, so now we'll do set start, and we will set it to the text node that we've passed in here. So text node, and then we'll set it to the start that we calculated in here, and then we will tell it to set end to text node, and then the offset will be the start plus text match dot length. So basically we're telling it to select everything from the start of the matching word, which in this case would be this. So we're telling it to select from here to, so like that's from hello from, yeah, that's, yeah, basically we're telling it to select everything that matches in here. So we're telling it to do that, basically just select at am side. That's what we're doing here. Then we will create a span element, which would use document.create element span and span, and then we would add the highlight class to it, which basically we need to create that class in here, highlight. And let me grab quickly what I was doing with this one. Color, columns color. I was using this color for now, and font weight bold. Damn it. For now, basically I'm using that, but the plan is to actually enable the user to pass their own class to the component, so they can actually change how the formatted words look in the editor. But for now we're just going to stick to this one, and yeah, we'll keep using it as it is, basically. Then next we will use, because we've now basically in the range. What is happening now is that hello am side 100 from, yeah, anything. Like what we have now is that this part of the text is selected. So what we're going to do next is we're going to tell the range object to surround everything that is selected with a node, and in this case it's going to be the span node that we just created. And then we will check if the user actually passed the final node. Then we'll tell it to use that final node, and I'll show you why I created that. Like we use it in certain cases and ignore it in others. If it doesn't exist, then we will just set the start to the span element and the offset to 0, so it's just basically at the beginning of the span element. And then we finally do range dot collapse true, so it collapses to the start. And I was about to save, which we shouldn't do at the moment. So that is the function that actually goes over a text node, and then just formats everything inside of it that actually matches the pattern that we have. This is not what actually does the splitting and basically like taking the node and the two adjacent nodes to it and removing them and converting them into the text node. This is not what is happening here. This is just the function that does the formatting. So what will end up happening basically is this, which I'll try, like I'll simulate this basically. There should be, maybe edit as HTML. So what will end up happening now is this: it would actually wrap this bit into its own class, and we will need to make this like that. So it will wrap it into its own class, and as you can see, because we've built the CSS at some point, it actually does the formatting for us. So that's essentially what we're doing when we use the range.surround contents. We're telling it to just take the word that we selected, which in this case was the @amsaid, and wrap it inside that span element, basically. So yeah, that is the function, and let's now go over the actual code. Okay, so we will now need to go in here. If you remember, we said that we're going to be using the input type, so that's what we're going to do. And here's how we're going to use it. We'll first check to make sure that it's actually defined, and we need to make sure that it's not the user pressing and the enter key or the return key to actually create a new paragraph. So that's what we're doing here. We're telling it, like, if the input type is anything other than inserting a new paragraph, then that's what we're going to do. So first we are going to create a selection. So document, const cell document dot get selection, and then if selection is defined, then we're going to do const range equals cell dot get range at 0. If range is defined, then here's what we're going to do. Basically, as I said, we in this case what we need is the immediate immediate child of the paragraph. So in this case, for instance, with this paragraph, we have 3 immediate children. This text node that contains hello and a space character, then a span element that contains a text node that has the text @amsaid, and then another text node that contains the space and from. So with the range, you usually end up, except for some special cases, usually when you do the when you get the start container or the end container of the range, you actually end up in the text node. So if I am here, then I am in the range.start container would be this text node, which is good because it's the immediate child of the paragraph element. However, if I'm here, then the start container of the range would be the text node that contains at AM Saeed. However, this text node is not actually the child of the paragraph, it's actually the child of the span element. So we need to basically get the span element. So what we're going to do is, first we will say let node equal range dot start container, and we'll convert it on the fly to an element. We need to also grab the start offset dot start offset, and then we need to check if node dot node type equal 3, which means that if it's a text node, because this is the number 3 is basically the equivalent of a text node, so we need to check it. We need to make sure that node actually is an immediate child of the paragraph. So is what, like, if not, we need to basically set node to the span element. So here's what we're going to do: if node dot parent element dot tag name equals span, then you'd actually tell it to set node to node dot parent element. If it's not, then node would just be the text node that we're using. Then, as I said, this is the current node. We now need to grab the previous node and the next node, so basically the two nodes that surround the current node. So we'll do this: const previous node equal node dot previous sibling or node dot previous element sibling. The reason why we're doing that is the difference between these two is that previous sibling would grab any node. So for instance, if this node the previous sibling would just grab the previous sibling, whether it's a text node or a span element or anything. The previous element sibling would only grab anything that's inside the span. So for instance, if we actually copy that one here, and let's say we're actually here, then the previous sibling would actually be this. There is a text node here that contains a white space. As you can see, if you look at this, it's a white space only text node. So previous sibling would actually grab that, and that's what we want. If there's a text element in here, we need to grab it. It should also grab the element if there's no text node, but just in case, we also use the node the previous element sibling in case that this one doesn't grab this. So that's the idea basically. So that's what we're doing here. We're creating the previous node with either the previous sibling or the previous element sibling. Then we do the same thing here. So node.next sibling or node.next element sibling. However, there is a small issue with this one, is that sometimes, as you can see here, for instance, let's say if we are the current node is this one, which is this. The next sibling is actually a line break node. However, we don't want that. Like if the next sibling is a line break node, we just don't want, we want to ignore that one and just basically say that there are no nodes that come afterwards. So that's what we are going to do here. We're going to say if next node, if it's not null, and next node as element, we're basically converting it to satisfy Java TypeScript. Tag name equals br. Then basically we're telling it if the next node is actually a line break node, then just ignore, then make next node actually equivalent to the current node. And for some reason it's complaining, I'm not sure why. Why is it complaining here? Because it's, sorry, it's constant. This needs to be let rather than const. Then what we're going to do next is basically we'll create a start node, which if previous node is defined, if we manage to actually find the previous node, then we'll use it. If not, then start node would actually be the current node. Then the start offset would be 0. So basically we're going to select, like, let's just delete this one, and let's say we have this, and this would be the previous node. We just want to select everything from the start to everything at the end here of the next node, which is this one. So we basically want to select all of that. So that's why we set the start offset to 0 of the start node, and then we'll do the same const end node equal either next node or node, and then we would calculate the text, the end offset. So if our end node is actually a text node, so that's what we're checking here, node type equal 3. As I said, number 3 is actually the text node. Then we would the end offset would be the length of the text inside that node. So end node dot text content dot length. Come on. Actually, we also need to make sure that end node dot text content dot length exists. If it's not a text node, because as I said, remember, sometimes like the node would be a span element, so this is not a text node, so we can't set the end offset to the length of the text. In this case, because we know our span elements will only have one children, so we will set the offset to one child. Basically, we'll always have just one child, which is the text node that contains the actual text. We will set it to the end. So if this was our end node, like let's say that our text basically was that, and we were editing something here, this would be our current node, but it would also be the end node. So, and in this case it would be the span element, and it would select everything as well. So that's what we're doing here. Then we need to do something here. Remember that we've got the offset from the range at the beginning. But the thing is, if this is the current node, then the offset is calculated based on this node only. However, what we're actually doing is we're selecting all of this, deleting it, and adding it again as non-formatted text. So the offset should be calculated based on the length of all of this. So that's what we need to do at the moment. We need to check if we have a previous node that is different from the current node, which is this one. Then we need to add the length of that text to the offset that we've already got from the range. So that's what we are going to do next. Let's just go here. If start node is not equal to node, and let me just do something here quickly, because this can create a problem. Not undefined. Start node dot text content dot length is not undefined, because if the text content is 0, then it like if we don't add is not equal to undefined, then 0 would also be false. But we just, yeah, it doesn't, like, it's not that different, but just to be safe, we need to make sure that it's not undefined. So if it's 0, it will evaluate to true rather than evaluating to false. Then we'll add the start node that text content dot length to the offset. Then we need to get the paragraph equal start node dot parent element, because we know that basically start node, node and end node are all basically a part of the like are all children basically of the parent paragraph. The next thing, we need to actually calculate where the start node is in the parent paragraph. So let's say, for instance, we've had something like this, where we actually have a span element. And let's say this is the current node, and this all of this is the previous node. This previous node actually starts at like 0, 1. It's at the 1 position of the parent paragraph, inside the parent paragraph. So we need to grab that position. So when we select all of that, delete it and re-add it as just unformatted text, we add it in the correct position. So that's basically what we're going to do. So we're going to do let offset in parent equal number, or not equal, it's going to be either a number or undefined. Then again, to satisfy, TypeScript will check that if parent paragraph is defined and it actually has child nodes dot length greater than 0. So what we're going to do is going to iterate over that children. So we're going to do for let I equal 0, I less than parent paragraph dot child nodes dot length, and then I plus plus. Once we find that So if parent paragraph dot child nodes I equal to start node, then offset in parent would equal I, and then we would just break because we've already found our element, like our start. We don't need to keep iterating over the whole nodes inside the paragraph. It doesn't make any sense. Then we'll come here and we'll check if offset in parent is not equal to undefined. Then here's what we're going to do. As I said, we're going to select from the start of the start node to the end of the end node. So range.set start node, start offset, range.set end node, end node, and end offset. Then we will convert all of that into non-formatted text by basically doing range.toString, which basically grabs any text that is selected inside the range and just removes any formatting and just convert it into a raw string basically. So something like this, if we have this selected, it will be converted to this, basically just simple non-formatted text without any just something that we can add into a text node basically. So close that one and come here, and we've converted it into a string. Then we will do this range.delete contents. So as I said, we need to basically just delete all of that, so that's what is going to happen. We'll delete it, and then to be safe, because sometimes the nodes do not get deleted, the nodes themselves do not get deleted, the text is deleted, but sometimes some of the nodes end up remaining behind. So here's what we're going to do. We'll just grab the parent element dot remove child node, and basically we'll do the same for this one, start node and end node. And then we will use the offset that we've already calculated here in this bit to actually add the text back in there. So we'll do this, so range.set start to the paragraph and to offset in parent, and then again we'll tell it to collapse, so it's not selecting anything and it collapses to the start, so it collapses to this. And now we can actually create the text node that is going to have text node equal document create text node. It would contain the text that we've already grabbed in here, and we'll then insert it, insert node text node, then we'll set the start to that text node, and then we'll either set it to the end text text node text content dot length, or if for whatever reason it's not defined, which again is not going to be the case, we'll just use 0, and then we'll collapse the range to the start. And finally we'll check if pattern is defined, which if you remember we have a state called pattern in here, a React state variable called pattern. So we're going to use that one. If it is defined, then we would just use the format function that we created, and we need to actually add it in here. Format and then handlers dot format. We need to pass the range, text node, and the pattern itself, and we're not going to pass the optional final node argument. We'll save and wait basically for the component to rebuild. This will get us somewhere, like you'll see that something like the text is going to be formatted, but there will be issues. It's not going to be working perfectly still, because there are a lot of things that just are not working properly. One of them is that we are not going to be able to recalculate the cursor position correctly. But let's say if I do that, as you can see now this is formatted automatically, but as you can see it just jumps to the beginning of the text, like so. I have to keep doing that. As you can see, like it's freaking out, it's doing a lot of weird things, there are just a lot of strange things happening. This is because basically we haven't calculated the recalculated basically the cursor position. And don't worry about how these things look at the moment. They are just like, it's a complete mess here at the moment. We're going to clean things up and probably split things into functions like we did here with the delete all editor children thing and the format function. But for now we just need to get things working, and then we can basically refactor and create smaller functions and do all of these stuff. Let me just have a sip of my water, because talking a lot makes my voice crack a little bit, and then we'll keep going. We'll recalculate the position next. Yep. Okay, so we're back, and here's what we need to do now. We need to so this is how we're going to recalculate the cursor position. Let me get Creator started, and new file, content, don't use white background, whatever. So remember that we've said like hello from we said that this is going to be a span, this is going to be a span, and let's say that we are in this this is the current node that we have, and the cursor was actually parked in here when the user did something. So the offset is 0, 1, 2, 3, 4. So we actually had the offset, the start offset that we grabbed, range dot start offset is actually, you said what, 0, 1, 2, 3, 4, and then we said that we would get the previous node, and we would if it's different from this, we would actually add the offset as well. So it would be 0, 1, 2, 3. So this is actually 4. We're adding the length of that text node. So we would add 4 as well, so that eventually the offset would be 8. We've also calculated the position of this node within the parent paragraph. So this is 0. All of this is just one node, so that's 1 here and 2. So offset in paragraph equals, what did we say, 0, 1, 2. So what we're going to do now that we've done the formatting is that we're going to go into the parent paragraph again and go into that position, and starting from there we would basically be counting the length of each node until basically the length is actually larger than the offset. Then this would mean that the node that actually makes the length longer is actually the one that the cursor should be at, basically. And then we would select that one and basically set the start of the range to it and recalculate the offset based on that. It's a bit hard to explain, or maybe I'm not really that good at explaining it, but yeah, it might be a bit more clear from the code itself. So let's just actually start doing it. So we'll create a variable called current length, which basically will hold the once we start iterating over the child nodes of the parent paragraph, we'll update that variable with the length of each node until we actually get to the point that we want. So yeah, let's just, enough talking, let's try to actually explain it. So we'll start from the offset in parents. We're not going to start from the very first child in the paragraph. We're going to start from where we actually inserted the text node and then we formatted, and then I less than parent paragraph dot child nodes dot length I plus plus, and then we do that, We'll grab the child because we're going to use it multiple times, so we'll just create child nodes I, and we need to make sure that the length, again this is just something to please TypeScript, is not undefined. So we'll check what happens, like if we add if current length plus child dot text content dot length is still less than the offset that we've calculated up here when we grabbed the start offset and then added the length, like the length of the text content of the start node if it's different from the current node. If adding the length of this child to the current length is still less than the offset, then what we'll do is current length plus equal child dot text content current length plus equal child dot text content dot length. If it is not, then that means that we've reached the node that we basically, where we actually want to park the text. So again, let me try to explain what is going to happen here, because it's can be a bit tricky. Just create something and let's so again we said hello from So again, let's say that the user, this is a span, and this is a span. Let's say that the user had the cursor initially parked in here, so the offset is 0, 1, 2, 3, and then we've added the length of this text node, which is with the 2 spaces and the 2 characters is 4. This means that the offset that we have is 7, and let's say we did something here, and let's say for instance that the user actually did this, so they made the text hello from Said to at 3, sorry, and they basically added a space here, so we have a space, just a text node with a white space, and then made that into a hashtag. So what would happen is we would start iterating from here, from this node. We would basically, current length would be 0. We would see current length plus 4, the length of this text node. Does it actually is it still less than the offset, which is 7? Yeah, so current length would be equal 4, because we would add it. Then we will come to this one and we check the length of this one is 1 2 3. One second. I'm just I know it works. I'm just trying to figure out how to explain it. This is 4. 1 2 3. Let me actually build the version that is working quickly, just to check, because something isn't making much sense to me at the moment. So what is the text that we had? Hello from, because either I am forgetting something here. Say to okay, so it's working properly. I think I'm forgetting something. Let me actually just go here and just go into the debugger to see if I seem to be missing something really. So let's see what the offset is in this case. Offset is actually 8. What is that? Range dot start offset. Okay, let me do again. Just see how everything flows from here, really. Yeah, I remember why. Because we're doing this. Because this is a space. Yeah, that's now I remember. Because we're handling the space differently. That's why things are not working properly. But yeah, essentially, basically, it does that, and then oh no, wait. It doesn't, because we're handling the space differently only if at the end. So no, we should be, this should be working. That's fine. So yeah, let's do that. We grab the selection, we get the range. Current node is it's this one. Yes, that's correct. Current offset is yeah, because we're calculating the offset after. So here it's 0, 1, 2, 3, but since we added a space, we've calculated, so the offset actually is 8 rather than 7. Let me just delete that and type it properly. That's why, yeah, I told you I'm probably forgetting something. The offset is calculated after basically the user presses the character or basically adds the input. So yeah, then we would add this 1, 2, 3, then it would be 7. Then we'll check this node. The length of this one is 1, so once we add it, it would be 8. Right. So yeah, let me just make sure. Ignore this one. This is what we want. Okay, previous node, it would be the text node, which is this. Yes, that's correct. Next node, in this case, as you can see, it's going to be a line break, so we will reset it to just current node. Do all of that. Start offset. Yeah, that's fine. Start the length of the start node, so the offset would eventually end up being 8, which is correct. That makes sense. It's fine. Okay, we now need to just go here. That's fine. We formatted everything, and then we have current length, which is 0. Let's just add in here. So for let I offset in parent, that's fine. Child is this one. Child is not defined. If child current length is 0, this is 4, it would be less than 8, so we would do that. So current length would be 4. We get back to it. Child, again, child in this case is this one. Current length is, yeah, it's less than 8, so we will add that. Current length is 7, that makes sense. Then we would get to, oh, this is not 1. No, it would be 1 because oh no, it's not 1. It actually gets deleted. So yeah, this is yeah, in this case that's fine because we still haven't actually formatted this one, so that makes sense. If current length yeah, okay, because now this is going to be less than that, so it would just yeah, sorry, I think I'm getting a bit tired, so I'm getting confused. So it's not going to, this is not going to be 8, like current length is never going to be 8. What will end up happening is adding this to it would be 8, which means it's never going to execute that part of the code. It's actually going to execute this bit, which it would subtract the current length from the offset. So 8 minus 7 would give us 1, and then we would set that that text basically to the range to start in this node with an offset of 1, which is here basically, which what we actually want. It's the equivalent of what we've had before if we ignore this bit in here. But yeah, I don't like that. I'm sure that was a bit confusing, but yeah, like if you just go through it, go through the code itself, it's sort of like it will make sense. So basically, if adding the length of the text content of the child will make the current length equal to or more than the offset, then we don't actually add it, we actually subtract it from the offset. So that's what we're going to do here, equal to current length, and then we would basically, if child dot node type equal 3, so if the child that actually if the child we actually want to park the cursor actually is a text node, then we'll just set the range dot set start to that child, and then we will use the offset. If not, we will set it to we just need to make sure that it actually has a first child. Oh, sorry, not if child not first child, then we would set the start to that first child. Basically, if it's a span, it means that we're setting it to the text node inside that span. Again, like the reason we have to check it is just to satisfy TypeScript, because we know based on what we're doing basically is that it should exist and it should be fine, but we're doing that to be safe. Range dot collapse true, and then we don't need to keep checking the other childs, we just break, and that basically does the recalculating for us. It recalculates the cursor position, and everything should be working properly at the moment. Let's wait until it finishes building. Yeah, it's done. So now if we go here and start typing, let me just check something quickly, make sure that this is actually loading the correct thing. It should be, I think. Just need to delete these, no need for these breakpoints, and